Hi everyone. This lesson is on factoring by grouping. All right, so here's some easy examples, but we're going to use it to justify the rules that we're going to use in this lesson. Let's look at the first one. Now we're to factor it. Factor the following: ax plus ay. What is the GCF for both terms? The GCF is a, right? So we factor out an a, divide both of them by a, and then whatever's left is written inside the parentheses. So that would be a, and then in parentheses, x plus y. I know it's a little easy, but it's okay. Right, in b, what's our GCF? What's common in both terms? Right, the x, right? So that's our GCF. That's written in front of the parentheses. And then you divide each term by the GCF, and whatever's left goes inside the parentheses. So x is written in front, and a plus b is written inside the parentheses. The point I'm making here is that whatever's written the same, whatever the same GCF is in both terms, that's going to be written in front, and whatever's left over stays inside. Here I used the Greek letter pi. A pi plus b pi. What's our GCF? Pi. Yeah, it's a Greek letter pi if you didn't know. So pi is written in front, and then what's left? Right, a plus b. Okay, part D. C happy face plus D happy face. Again, it could be a letter, it could be a Greek letter, it could be a symbol, but the GCF in this case is happy face, right? So the happy face goes in front of the parentheses, and the C plus D is written inside the parentheses. Okay, so it doesn't matter what it is. It could be a binomial. So in part E here, what's the same on both sides? It's not just a letter, it's not just a symbol, it's a whole binomial, x plus y. So we're going to write that x plus y in front. Now because that's in parentheses, it has to stay in parentheses. And then whatever's left over from each one, excluding the x plus y, is what's left in the second parentheses. So the answer is going to be x plus y times a plus b. Now one thing about that problem is if you decide to write the a plus b first, that's okay, because that's called a commutative property. The commutative property for multiplication says that the order doesn't matter. So if at any time you have it in different order with multiplication, it's not a problem. All right, so for part F, what's our GCF? 2a minus 5b. And then what will be left over in the second parentheses? 3x plus 4y. Okay. So we're going to use that as a general statement. So we're factoring a binomial from a polynomial. When the greatest common factor is a binomial, whenever you see the same thing, that's written first, and then whatever's left over goes second. So a times x plus y plus b times x plus y is x plus y times a plus b. Both of them have to be in parentheses. If you do not write the x plus y in parentheses, then it would be considered wrong. All right, so here's example 1. What's our GCF? 3a plus 2b. So that's going to be written first. And then whatever's left over is going to be written in the second parentheses. So our GCF is 3a plus 2b. That goes first. And the second parenthesis is going to be 2x minus 5y. There's your answer. You don't have to write it twice. I just wanted to kind of go through it and show it by steps. All right. Try number 2. Remember to always pause the video so you can work on it. All right, 2x minus 7y times 5x minus 3. So the 2x minus 7y is written twice. You write that first. And then whatever's left over from both of them, excluding the 2x minus 7y, that goes in the second parentheses. Again, if you have 5x minus 3 times 2x minus 7y, that's also okay. So the order doesn't matter. Because of what property? That's right, the commutative property. All right, here's another example. Notice that the 2a minus 3, it's the same in both sides of the minus sign, but there's not a number in front of the parentheses, the second parentheses. There's not a number or a letter, so we could always put what number in front of the parentheses. Yeah, that's right, you could always put a 1. So whenever there's not a number, you could always put a 1. In this case, it's a minus sign, so it's a negative 1. If it was a plus sign there, then it would be a positive 1. All right, so now the 2a minus 3 is our GCF. And then the 6y minus 1, that'll go inside the second parentheses. Okay, so those were problems that were already halfway set up, so to speak. So now we're going to talk about the full problem, factoring by grouping. Some polynomials can be factored by grouping terms in such a way that a common binomial factor can be found. So here's our first problem, ax plus bx plus ay plus by. There's 4 terms. If you notice, all 4 of them do not have a common factor. There's nothing that they all have in common. So what we're going to do is we're going to group it. We're going to find the GCF from the first 2 terms and the last 2 terms. So we're pairing it up. First 2 terms and last 2 terms. First 2 terms, what's our GCF for the first 2 terms? Yeah, that's right, x, right? And then what's our GCF for the second 2 terms? Yeah, that's right, y. That's what we're doing. We're looking at the first 2 terms and the last 2 terms. So we factor out an x from the first 2 terms, we get a plus b. And if you factor out a y from the second 2 terms, what will you get? Yeah, a plus b. Now, it's a positive. The first term is positive, so that means our GCF is positive. We need to put a plus sign in between the parentheses. So plus y times a plus b. Now our GCF is a plus b, so that'll be written first, and then x plus y will be written second. Okay, here's a couple more examples. What's our GCF for the first 2 terms? And then find the GCF for the second 2 terms. So first 2 terms and second 2 terms. GCF for the first 2 terms, that'll be 3x. So factor out a 3x from the first pair. So divide each of them by 3x. 3x goes into 6x squared 2x. And then 3x into negative 9x will be negative 3. Now our second pair. What's our GCF? Let's see, for -4 and 6, that would be a 2. Then they both have a y in common, so it's 2y. Oh, but the first term is negative, so it will be -2y. So now we could factor out a -2y from the second pair. And then notice the two binomials in parentheses are alike. They're the same, so we could factor that out. So it's 2x minus 3 times 3x minus 2y. All right, next one. Again, break it up into pairs. What are we going to factor from the first pair? Yes, a 5x. And then what are we going to factor from the second pair? They don't have anything in common. So when they don't have anything in common, we're going to put a 1. So if the first term was positive, you would put a +1. Since it's negative, we're going to factor out a -1. That'll change the signs all the way through. Now our binomials match. If they don't match, then we know we've made a mistake and we've got to stop and go back. So there's our final answer. 3x minus 4y times 5x minus 1. Okay, so here's the news on this one. These two problems. Sometimes you have to rearrange the order. How do you know if you have to rearrange the order? If it doesn't work. Right, so the last ones we didn't rearrange it. We could have, but they worked, right? So we look at the first two and the second two, and you might think we have a problem, right? There's no GCF for the first pair or the second pair. So that means we're going to rearrange it. So let's bring down the first term and then decide what should we have second. Well, if we have a 6ax first, what should we put next? What does it have in common? What's in common with another pair? Well, how about the 3bx? Not only do they have an x in common, 3 will go into both terms. Okay, that sounds good? Okay, so now we have two more terms left. We have a -5by and a -10ay. We just need to decide which one should go first. Well, in the first two terms, there is an a and a b, and the a is in the first term and the b is in the second term. So in our second pair, we should try to keep the same pattern. An a in the first term and a b in the second term. So what should be third? The -10ay and then the -5by. That looks like it'll work. All right, now we're going to do the same thing. Factor the GCF for the first pair and the second pair. What's the GCF for the first pair? That's right, 3x. What's the GCF for the second pair? For 10 and 5, it'll be 5, and they both have y, so it'll be 5y. Oh, but the first term is negative, so it'll be -5y. And then we get another 2a plus b. 2a plus b, the 2a plus b matches, so that's written first, and then 3x minus 5y is second. All right, last example. Same problem, right? Nothing common in the first pair, nothing common in the second pair. So if you're taking a test, it might not tell you to rearrange the terms. When do you know to do that? When you try to factor it and it doesn't work. if you try to factor it in the order it's in. So now we're going to rearrange it. 2bx, what should go second? Well, you have a choice. You could put the 2by or the cx. I want to put the cx first, but you could put the 2by. Right, so there's not always just one order that'll work. All right, so the next pair, let's see, the 2by or the cy. What should go third? We're going to put the 2by third, and then the cy fourth. Now we could factor the GCF from the first pair and the second pair. X from the first pair, and y from the second pair. The binomials match, so there's our final answer. 2b plus c times x plus y. All right, good luck on your homework. I'll see you here for the next one.